Hi all, and welcome to a Pro Build video where we'll focus on installing the motor and sensor connections. This video is supplementary to the written instructions, which are linked below. This is a very important step for you as a CNC user, and it will help you understand the fundamentals of how each motor and sensor plays a part and its specific role. Let's talk about proximity sensors for a moment. Our kit includes the Pepperl-Fuchs NPN inductive proximity switches. This kit provides a complete solution to automatically home your CNC machine, square your gantry, and provides active safety limits to prevent crashes and to protect your machine and workpieces. These are inductive, so they will determine when metal is close to them, which triggers a sensor. To learn more about proximity sensors, check out the description below for a video all about this topic. Alright, let's learn about the motor and sensor locations. We have the x-axis, the y-axis, and the z-axis. The depicted axes and sign conventions correspond to Avid CNC's Mach 4 configurations. You can change or customize these Cartesian coordinates in Mach 4 later on if you prefer. Let's review our motor locations. We have our Y1 motor, our Y2 motor, our X motor, and our Z motor. If you have an optional rotary, you will also have an A motor as well. For our sensor locations, we have our Y1- switch, our Y2- switch, our Y2+ switch, X switch, and Z+ switch. Let's also review our sensor flag locations. There is a Y1- sensor flag, the Y2 sensor flag, and Y2+ sensor flag. Best viewed from the back of the CNC machine, we have the two X gantry sensor flags. This is a very detail-oriented process, so be sure to read the written instructions thoroughly, which we've linked below. Let's go ahead and label our motor and sensor cables on both ends. Here I'm using cable labels that are readily available online, and I've linked to a listing in the description below. A label maker, electrical tape, and a Sharpie would also work well for this. This way, when we run our cables through the cable track, we'll know which is which when we need to plug them into the controller. Depending on your machine dimensions and configuration, your cable lengths will be different. Be sure to check the chart and diagram in the written instructions to determine which length cables are for which motor and which sensor. Let's label our sensor cables as well. Be sure to differentiate between the right angle cables and the straight cables. The Z+ and X switch will be using the right angle connector. The Y1-, Y2-, and Y2+ switch will use a straight connector. Let's take one of our cube sensors and attach a straight connector sensor cable. Then we can install the sensor on the gantry riser. Use this procedure to install the Y1-, Y2-, and Y2+ switch sensors. Then we'll install the Z+ sensor. Position the sensor 22 mm or 7/8 of an inch from the bottom of the Z-axis motor mount plate. You can now attach the right angle connector end of the Z-axis sensor cable to the sensor. This will feed directly into the gantry cable track. Now onto the X sensor. Install the X- and X+ sensor flags at the indicated locations in your instructions. Locations may vary depending on your gantry width. Next, we'll guide the X rack and pinion plate over toward one of the X sensor flags. Then locate the hole on the back of the gantry rack and pinion plate and thread in the cylindrical sensor until it touches the surface of the sensor flag. Then back the sensor out 3 full turns and lock it in place with a jam hex nut. Then thread on the right angle connector end of the X-axis sensor cable. To open the cable track, use a screwdriver to lift open the individual cable tracks. A flat head screwdriver with a particularly narrow head works best. I recommend running all of the sensor, motor, and spindle cables through the tracks prior to closing the cable track clasps. Now let's cover how the cables flow through the cable track. Let's follow the diagram to run the cables through the gantry channel and cable tracks. The blue line is a Z motor cable, and it flows through the gantry cable track and into the table cable track. The red line is the X motor cable that will flow through the gantry cable track and into the table cable track. The green cable is the Y1 motor cable, and this will thread through the inside of the gantry extrusion and into the table cable track. The orange line is the Y2 motor cable and flows directly into the table cable track. Here is a diagram for how the sensor cables run through the cable track. The blue line is a Z sensor cable and it flows through the gantry cable track and into the table cable track. The red line is the X sensor cable. It will flow through the gantry cable track and into the table cable track. The green cable is the Y1- sensor cable, and this will thread through the inside of the gantry extrusion into the table cable track. The orange line is the Y2- sensor cable, and it flows directly into the table cable track. Lastly, the purple line is the Y2+ sensor cable, and it flows directly into the table cable track. Let's plug in our motor cables to the corresponding motors and run them through the cable track along with the sensor cables. Here we'll plug in the Z motor and the X motor. The Z motor, X motor, Z+ sensor cable, X sensor cable, and the spindle cable will route through the gantry cable track. We'll plug in the Y1 motor cable. Then we'll take the Y1 motor cable and the Y1- sensor cable and thread it through the gantry extrusion and out the other side. Next, let's plug in the Y2 motor to the Y2 motor cable. Then gather all of the cables to route through the table cable track. Once we have all of the cables through the track, we can move on to the electronics enclosure installation. The cable track can be installed on the right or left side of your machine depending on your shop needs. Be sure to mirror the flow of the cables through the system. You'll need to make sure that the locations and sensors still conform to the instructions. Now we can move on to the electronics enclosure installation. I recommend plugging in all the motor, sensors, and other components into the electronics enclosure prior to hanging the enclosures on the machine's electronics bar. At the indicated locations, remove the plastic plugs from the plug-and-play electronics enclosure. At the locations with the removed plugs, attach the mounting brackets. Let's go ahead and place the controller on a riser, such as a piece of scrap wood like I'm doing here, to offset the brackets from the floor, or go ahead and place it horizontally on the bed of your machine. Now we can plug in our motor cables that we've labeled to the corresponding inputs. We have the X motor cable, the Y2 motor cable, the Y1 motor cable, and the Z motor cable. Then we'll go ahead and follow up with the sensor cables. We have the X sensor cable, the Y1- sensor cable, the Y2+ sensor cable, the Z sensor cable, and the Y2- sensor cable. If you have a rotary attachment, you can plug in your A motor cable and A sensor cable. If you have a second Z-axis, rather than a rotary, you'll plug in the second Z-axis motor to the A port. The E-stop will be plugged into the input labeled E-stop. The Auto Z and corner finding touch plate will be plugged into the AUX1 sensor port. Your Ethernet cable will be plugged into the Net1 port. This will connect directly to your computer. The relay options can be used as an auxiliary input power for a router or dust collector. If you've chosen a router as your cutting tool, you can plug in one of the two AC power cables to relay one in, and then plug in the router cable to relay one out. The other AC power cable is for the main control unit. If you have the plug-and-play spindle, you can plug in the control cable with the 14-pin locking connection. This will be the connection between the VFD enclosure and the CNC control electronics. Then attach the plug-and-play electronics enclosure to the leg kit at the indicated locations. Now we can plug in the AC power cable to the side of the controller box below the on switch. You can connect this to the wall outlet. Next, we'll cover the VFD and spindle electronics setup. Follow the written instructions to install the spindle on your Z-axis. We'll plug in the industrial high flex cable with locking M23 connection to the spindle and then run it through the cable track. This will be the connection between the VFD enclosure and the spindle. Plug this in to the bottom of the VFD electronics enclosure, and then we'll plug in the controller cable with the 14-pin locking connection into the bottom of the VFD electronics, which connects to the control electronics enclosure. Now you can plug in the VFD power cord to your wall outlet. On to cable management. We'll use the cable ties and tie mounts to secure loose sensor and motor cables. Ideal locations for this will be on the riser extrusion above the Y1 motor, on the back of the gantry extrusion where the cables exit the gantry cable track, and on the back of the riser extrusion where the cables enter the table cable track. Attach the cable bracket to the electronics mounting bar, and then you can coil any excess length of cables and hang this on the cable bracket. That's all for the electronics assembly and installation. You're now ready to proceed with the machine setup. I can't wait to see what you make, and I'll see you in the shop.